Despite the worldwide importance of natural history collections, most are at risk because they are critically underfunded or undervalued. A significant contributing factor for this apparent neglect is a lack of a professional reward system, one that articulates and quantifies the breadth and depth of activities and expertise required to maintain, digitize, mobilize, and enhance data deriving from collections. If people throughout the full value chain and natural history collections received professional credit for their efforts, ideally recognized by their administrators and funding bodies, they would prioritize traditionally unrewarded tasks and could convincingly self-advocate. Proper methods of attribution at both the individual and institutional level are essential. Indeed, GBIF itself has prioritized a focus on people. The very first planned item in their implementation plan for 2017 to 2021 and their annual work program states a desire to develop mechanisms to support and reflect the skills, expertise, and experience of individual and organizational contributions to the GBIF network, including revision of identity management system and integration of ORCID identifiers. They've explicitly recognized that ORCID is the solution to best capture and resolve the identity of people in academia and professional settings. However, a bottleneck that prevents the full execution of GBIF's plan is a legacy of seemingly intractable text-based content shared from natural history museums that ambiguously record people or organizations implicated in specimen data, none of which include any predetermined links to ORCID identifiers or any other identifiers for people. Typical content shared under the Darwin Core terms recorded by for the collector and identified by for the determiners is unstructured and highly variable. They might include ordered or unordered people names, suffer from insensitivity to cultural preferences, they might express the full or abbreviated names of organizations, or indeed include combinations of people and organization names. As a direct consequence of a reward system, if there was such a thing, the wider biodiversity community would finally benefit from a rapid way to obtain accurate answers to questions such as, who's an expert collector or determiner of taxon X? Or a more refined question such as, who is an expert taxon collector of a particular region of the world? Or indeed, who has collected a particular place in the world and as a consequence ought to be intimately familiar with the local collecting regulations and know how to apply for collecting permits, without having to resort to sending out blast email messages to colleagues or, heaven forbid, mining the taxonomic literature for that kind of information. So use cases like these and others are met in surprising ways if we had a mechanism to unequivocally stitch people and their identities in academia to legacy specimen data, and also formally codify their actions taken in the identification or the collection or the care or the maintenance of those specimens. My Bloodhound proof of concept for the Ebbe-Nielsen challenge this year aims to do just that. Let's have a quick cursory look to see how this proof of concept works. Well, first of all, you'll notice that you have this option to log in to ORCID. So I'll go ahead and do that right now, and I have an ORCID account, and we'll see how that works. Here I'm redirected to the OAuth 2 mechanism where I can authenticate to ORCID, and I go ahead and do so. Then having done so, I get redirected back to the application, and here it's see that the system has recognized who I was, and that information has come from the publicly available information within my ORCID account. So the first button I've got here is to claim my specimens. So I'll attempt to do that, and as you see immediately is a list of specimens here that are purportedly collected or identified by me. I can see a few individual names like colleagues of mine from years past in some of these columns, but I also do see my name identified by in a number of these specimens. Others in here are other members of my family. Here's my father, for example, and way down here I see my mother, who is also deposited specimens at an institution. So here I have the option now to declare which of these specimens that were potential candidates that I've been responsible for in some way, shape, or form. I can declare whether or not that I've either identified a particular specimen or collected it, or both. So in this case, I've identified that one, and I've identified that one, and I've identified that one, but these other ones here are not relevant. They're not mine. So if I go back to my profile over here, I can see the 3 specimens that I've claimed as belonging to me or either collected or identified by me, and I can remove them if I've made a mistake. Or indeed, I can even make my profile public, such that perhaps back at the home page there might be examples of accounts of people who've declared the actions that they've taken on the identification or the collection of the specimens that they've been responsible for. Download that as a CSV file or as a machine-readable JSON document. So that's the basic concept for the Bloodhound application, allowing you the ability to claim the natural history specimens that you've either collected or identified, and at some point, perhaps in the future, receive credit. Behind the scenes, you'll also notice here in the tagline that you have the ability to be notified of taxonomic changes. What I've done as a mechanism to try and incentivize this whole process of declaring what specimens that you've either collected or identified, because I recognize that it might be very tedious to do that time and time again for the tens of thousands of specimens that you might have been responsible for, is a notification system in the event that your specimens have been re-identified and are now being shared under new taxon concept, for example. If you had deposited type specimens, that might be rather interesting information for you to receive at some point in the future if, for example, your taxon has been split or merged with another and the data have been reshared under a new name, then that would be very interesting information for a taxonomist. So that's one mechanism to try and incentivize this whole process, and I undoubtedly, with a bit of creativity, we could come up with other mechanisms to try and encourage people to tag their specimens and claim them as those they might be responsible for. People names are notoriously difficult to reconcile. They are harder to deal with than other entities like dates or place names because people have more than one name. Names change throughout a person's life. They may come with abbreviations, nicknames, various ordering patterns, and their contents or structure are dependent on cultural practices. For a thorough primer on these and other issues, I refer you to an older but very useful W3 document entitled Personal Names Around the World. If the goal is to attribute to people the actions taken in the production and care of specimens and their data, we have to use a combination of sophisticated domain-specific algorithms and heuristics, as well as basic high-performance search. Bloodhound makes an attempt to do these things. Two of the more interesting algorithms at play involve parsing and subsequent reconciling of people names. Full credit for parsing in Bloodhound goes to Sylvester Kyle, who developed a Ruby gem called Name that does an excellent job of parsing and comes with a number of useful configuration options. Once parsed, people names in Bloodhound were reconciled using a bespoke weighted graph algorithm. Edges in the graph were given a score dependent on the prevalence of shared co-collectors, the range and overlap of dates for an agent's collection and determination activities versus that of another's, and the kingdoms of taxa collected. Here's one such graph with the surname Bain. The nodes are clustered by initials, and the edges are computed similarity scores. Most nodes are computed to have edges with a score of 0.5, or 50% likely to be the same person. Some, however, had shared co-collectors, similar spans of overall collecting and determination dates, or similar taxa collected and identified. So for here, for example, we have John F. Bain, John Bain, J. F. Bain, J. Bain, James Bain, etc., etc. And there's another little cyclic graph over here for R. H. Bain, or Raoul Bain, or R. Bain. So these graphs were all computed for all surnames that were shared across the entire corpus of Bloodhound. And some of these edges here have much higher scores. So for example, the edge between John F. and J. F. Bain was computed to be 0.8 in all likelihood because in the recorded by field of the Darwin core for a group of specimens, the instances of John F. Bain would have a series of co-collectors that are also shared by J. F. Bain, resulting in a much higher score on the edge of this particular segment of the graph. In this case, the nodes John F, John, and JF likely represent the same person, and the node John F was chosen to represent the canonical node for all three. All the collected and identified specimens for John and John F were then reassociated with John F, and the result is a more thorough list of specimens attributed to the person John F. Bain. Graphs like these were pruned to find these so-called cliques of strongly connected nodes, and the result of that particular algorithm looks like that. So here is an indication that John F and John and JF are likely to represent the same person, and then all the residual nodes that didn't quite pass the mark were then treated as independent nodes that are unresolved. So there's insufficient information there to determine whether or not RH or Raoul or R. Bain are indeed the same person. The next step for the Bloodhound proof of concept is to enhance and transform how people names are initially transcribed and recorded at the source when a specimen record is first digitized, rather than doing it after the fact. Specimen collection management systems often do not have this degree of granularity, in large part because there is not yet a mechanism to share these data, nor an aggregator to make use of them. Thankfully, the Joint Research Data Alliance and Taxonomic Database Working Group launched a task last week in New Zealand and have now decided to work on an extension to Darwin Core to help codify and formalize how to share this kind of information, and for aggregators to eventually develop more robust ways to assign attribution. Maybe one day soon we'll have an alt metric that includes natural history specimens, just as we now have for publications and datasets.